Hi everyone, my name is Heather King and I'm a PhD student at the Auburn Shellfish Lab, and today I'm going to be telling you a little bit about the development of a breeding program for the Gulf of Mexico eastern oyster using communal rearing of families. And some of you might be familiar with it being called the SALT program. The eastern oyster supports large markets throughout wild harvest as well as aquaculture production along the East Coast and the Gulf of Mexico within the United States. Declines of wild populations, though, have resulted in increased interest in aquaculture production to support the growing industry that you all work in and restoration efforts of wild populations. Selective breeding is used along the East Coast to combat these population declines, but until recently, the Gulf of Mexico hasn't had a structured breeding program for the eastern oyster. So, luckily for us, in 2019, the Gulf State Marine Fisheries Council funded the initiation of the SALT Consortium to produce selectively bred lines of eastern oyster for improved performance in low and high salinity environments in the Gulf of Mexico. Structured breeding programs of eastern oyster typically use a family-style breeding program where the crosses are kept separate throughout the entire culturing period. But here in this program, we've used a common garden with walkback selection. And this design consists of producing your crosses and then pooling them post-fertilization in communal rearing tanks. Following that larval culture of oysters in the hatchery, they're then placed at testing sites for grow out, and at harvest, we measure traits like height, length, and width, and then the oysters are genotypes so that we can assign parentage, so basically tell you how they're related and who their parents were. And from that, we're able to estimate breeding values and select the best parents for the next generation. Just like in the title, we're walking it back with that selection. So after the initiation of this breeding program, broodstock oysters were then collected from 17 different wild reefs all across the Gulf of Mexico, and that ranged from Texas all the way to Florida. And from those populations, we created a genetically diverse founding population. So these are the oysters that we use to produce the F1 generation or that first generation in 2020. And then in the spring of 2021, we distributed the offspring from that first generation to 7 grow-out sites throughout the Gulf of Mexico, and we tried to capture sites with varying salinity patterns so that we could see performance of these families in these different salinity environments, because we've heard of differential performance in low areas as well as high salinity areas, which a lot of people in Florida do experience. Then following that grow out period in the spring of 2021, that first generation was harvested from 4 of those 7 sites, and those offspring were genotyped. And we used that to assign parentage and calculate those breeding values like I talked about in the previous slide. So here are those 4 sites that we harvested in that first generation. 3 of those 4 sites had the typical variable salinity pattern that we see in the central Gulf of Mexico, where we have those low salinity swings for extended periods of time, but the salinity is very up and down throughout that grow out period, as you can see those first 3 graphs from Mobile Bay, Alabama, Deer Island, Mississippi, and Grand Isle, Louisiana. And then we only had 1 high salinity site, unfortunately, that we were able to harvest from, but as you can see here, that Alligator Harbor site in Florida did have very consistently high salinity, up near 30 ppt and above throughout the grow out period. So there were some main conclusions from that first generation, but the one that I really want to focus on is that 4th one in the box at the bottom. And that was that family distributions indicated that there was differential survival between the low and high salinity environment. So after we looked at the distribution of families between that low salinity environments that we harvested from and the 1 high salinity site that we harvested from, we did see that there were certain families that performed better, if not completely disappeared from the low salinity site, but were still present at the high salinity site, showing that there is differential survival among these 2 different salinity environments. So going from here, we decided to split the program into 2 and develop a high salinity line and a low salinity line that would be used for performance in these 2 different environments. The next step from there was to create the next generation, so the F2 generation of oysters. And we used the breeding values that we calculated in the previous generation to develop selected lines for a high salinity environment and a low salinity environment. So not going into too much detail on this, pretty much we just wanted to have a positive differential of breeding values for the two selected lines. So here you can see the low line had a positive percent of 5.39% increase based on their breeding values. So their breeding values are 5.39% greater than the previous generation. And then for the high line, the breeding values were only 2.61% greater than the previous generation. And the reason we weren't able to achieve as high of a differential was because we had lower broodstock numbers, because one, we only had one high salinity site to select from, and two, we did have some tag losses as well as mortalities of those high salinity oysters before we ended up being able to spawn them. So we didn't have as many animals to choose from when trying to take the best individuals from the first generation. So we produced the low salinity line at the USM research site, and we produced the high salinity line at the Auburn University Shellfish Lab. And they were grown there according to best management. And once they reached a size of R6, so they were retained on a 6mm mesh, they were then deployed to 6 different grow-out sites. And at these sites, we monitored survival, growth, as well as salinity. And bags were just split throughout the grow-out process to maintain densities as well as to maintain fouling of gear. And again, the sites that we chose for the grow out were based on historical salinity in those areas. So a lot of these sites were the same sites that we had used in the previous generation, with the addition of another high salinity site located in Indian Lagoon, Florida, as another high salinity site. So the low salinity selected line and control line were deployed at Grand Bay, Alabama and Mobile Bay, Alabama from November of 2022 to September of 2023. And we were able to monitor growth as well as survival throughout that time period. If you look at the graph here, the dotted black line is the Grand Bay selected line, and then the dotted blue line is the Mobile Bay selected line, and these are both sites found in Alabama. The lines that are not dotted, so the straight lines, blue and black, are both the control lines that we were comparing these selected lines to. Here you can see that the shell height of the selected line at 10 months post-deployment was significantly greater at both the Mobile Bay and the Grand Bay sites in Alabama. And up here you can see that at the Grand Bay site, the selected line was 5.82 millimeters on average greater than the control line. And at the Mobile Bay site, the shell height at 10 months post-deployment was 4.33 millimeters greater than the control line 10 months post-deployment. And there is some more data past 10 months, but I have not worked through that data yet. Additionally, we monitored survival or mortality. So this graph actually shows interval mortality because we did have 2 peak mortality events at these 2 sites. So it does show that significant difference between the selected line and the control line. So at Grand Bay, we had a peak mortality event during May of 2023, and at that time point, the selected line survived 7.96% better than the control line. And then following that sampling period, 2 months later in July, Mobile Bay also had a mortality event, and the selected line had 12.92% greater survival than the control line, and both of these were significant. So the selected lines did survive significantly better than the control lines that were deployed at the same sites. On to the high salinity sites. We had a high salinity site at Alligator Harbor, Florida and Indian Lagoon, Florida. And here we had to more so look at growth rather than just that final shell height at each of these sites, because the high salinity select line was produced prior to the control lines, and they were not able to be deployed at the same exact size. So the control line was lagging behind the high salinity line a bit. So between both of the sites, there was no significant difference between growth between the select line and the control line. Here, the select line is the dark line and the control line is the orange line. But one thing to take note of is that between the last sampling periods at Indian Lagoon, the one bag that we did measure at the Indian Lagoon site of the select line had an average growth 6.36 millimeters greater than the control line. The only problem there is that we only measured one bag at that sampling period, so we weren't able to perform any statistical analysis on that. So we can't say that there was a significant difference in growth between the select and the control, but we did note that we saw a large difference in growth between the selected line and control line. So hopefully in the following generation, we'll be able to look at that more thoroughly and determine if there is a good difference in growth between the selected and control. One thing to note as to why maybe we did not see as much difference in growth between the selected and control at the high salinity sites is if you think back to when we made the selected lines versus the control line, we weren't able to get as large of a selection differential in the high salinity line because we had lower numbers of broodstock. So that could be something that created a problem, and we're hoping to amend that in the following generation. Again, here the selected line is the dark dots, and then the control line is the orange dots. And the survival of the selected oysters, there were no significant differences at the Alligator Harbor site between the two lines, but at Indian Lagoon there was a significant difference seen between the two lines at the final sampling period, where the selected line had 5.54% greater survival than the control. And then during our April sampling, we only sampled one replicate bag of the high salinity selected line. So again, we weren't able to perform any statistical analysis on that, but it is good to note that within that one selected bag that we did sample, it had 27.13% greater survival than over the control bags that we sampled at that point. Some summary and conclusions from the second generation of the selected lines. So for the low salinity selected site, we did see significant differences in survival as well as growth between the low salinity select and the control lines. And the control line suffered significantly greater mortality during those two peak mortality events that we looked at in the previous slides. And in the previous generation, we did not directly select for survival. Rather, we had animals at these low salinity sites and chose the best performers in these environments. So there seems to be some correlated response between growth and survival in these areas. And then at the high salinity sites, we did not see any significant differences between survival and growth at the Alligator Harbor site, but we did see at the Indian Lagoon site significantly greater survival of the selected high salinity line compared to the controls during that sampling period, during the final sampling period where we saw some mortality occur. And then we also did see some trends in some of the sampling periods that we weren't able to do statistical analysis on, but we saw a trend towards faster growth in the high salinity selectine at Indian Lagoon during that last sampling period, as well as in the month of April, we saw 27% greater survival in that one bag of selected individuals that we sampled compared to the control bags, which is promising. We did have a much smaller response to selection at the high salinity site. And again, this is probably because, one, we only had one high salinity site in the previous generation to choose from, and we weren't able to get as much of a differential in that generation. But hopefully going forward, we are able to make a difference in that. So going forward, there's a couple things that have been ongoing and happening. We're doing different challenges in terms of low salinity, heat stress, and disease resistance, and most of those are going on at the University of Southern Mississippi. They'll also be doing some genomic selection projects, and they're doing that with Texas A&M. And then the big one for you guys is we will be doing a triploid comparison of the selected lines. So we'll be seeing how the performance of the low salinity and high salinity selected lines translates into triploid production. We'll be growing those out at farm sites, so we'll be able to see how they survive as well as how they grow compared to diploids as well as compared to a control oyster alongside. So we'll have some good information from that later on in 2025, and I hope to get that to you guys as soon as possible, and maybe we'll look into collaborating with some of the farmers over in Florida if we're able to see how the oysters perform on your farm as well. If you have any questions, feel free to ask me. My contact information will be on the last slide of this PowerPoint, as well as Leslie can get you my contact information as well. And thank you guys for having me, and I hope everyone has a great day.